Ladies and gentlemen, boys and girls, welcome back to TechForge for part 2 of the GTX 970 mods and clocks video. Today we'll be looking at what we can achieve after we've done the mods that we have, what sort of overclocking results we get, and just find out, was it all worth it? Stay tuned. Just as a quick recap from the last video, we took the GTX 970 Phantom, freshened up the thermal paste and strapped a 120mm Silverstone slim DC fan to the heatsink, just to try and get some better cooling and thus better overclocks. Ghetto looks aside, we'll find out how well this has worked and also give thanks that the tinted tempered glass on the BitPhoenix Aurora case hides all the nasty gubbins seen here from sight. Okay, so this is just a quick temperature test between the modified version and the pre-existing version. As you can see, the settings in MSI Afterburner are the same, the power settings, the clock settings, all that gubbins, and also the settings for Unigine Valley are also the same as the previous run. We're just going to do a quick run for 15 minutes on the bench and log some temps. So we're 15 minutes into the run, and we can see that the temperatures are reduced from the original stock configuration. Now this particular run on the video had the side panel off for a good 5-10 minutes at the start of the run, so she only peaked at 73 degrees. I did the run again with the side panel on, and it peaked at 75 by the end, so I'm going to call that a 75 degree run. Meanwhile, peak power was 116%, so that shows that this particular chip will draw 116% in stock configuration, which tells us that in order to overclock any further, we're going to need to increase the power target. The way to do that is to use a couple of programs. One is called Maxwell BIOS Editor, and the other is called NV Flash with certified checks bypassed. Now before we go any further, I'm going to go ahead and just pause this video because I want to put a disclaimer on here that flashing your BIOS with a custom BIOS does carry its own risks. You do this at your own risk. There is always a risk that you could destroy, damage or brick your card, so keep that in mind if you're going to attempt this. Right, so with that out of the way, we'll just simply drag the standard ROM into the program, and that will load up the ROM into Maxwell BIOS Editor, and you can then go through all the different tables, but I'd leave all of those alone for now. We're not going to mess with any of those. We're just going to go straight to the power table, because power is what we want to change. Once in the power table, we're going to be ignoring most of these little sections of 3. The first one's your TDP, which you can change if you'd like, 300,000, but that's no biggie, we're not going over it. The third one you don't touch, that is your PCI Express lane power connector, or the power limits for that connector. The following 2 you will want to change, and the third one that I've highlighted there also. So that's 4, 5 and 6 in the groupings. The first 2 of those, the 4 and 5, is your PCIe power 6 pins, or 6 and 8 pins, whatever you've got there, and the last one is your overall percent power. Now we're going to want to knock both of those up to 125% each, so 125% on the power, 125% on both the PCIe cables. Once you have your values all lined up, you can then save the ROM by hitting Save BIOS As. Now save that file because that's the one you're going to be loading into the NV Flash to flash your BIOS with. At this point we're going to disable MSI Afterburner for safety, go to Device Manager, disable Display Adapter. That's so we can do the BIOS flash. You must disable it. Just a drag and drop into there will get it started, and all you have to do is press yes and you're done. A quick reboot of the PC and we're back into MSI Afterburner, and looky here, 111 up to 125. Booyah! That's a bit more like it. That's going to give us some headroom for sure. That could have gone a little bit hungrier for about 135 or so, but 125 will be fine for now. But that's enough of me prattling on. Let's open up some superposition and see what we are dealing with now with 125% power limit. Okay, so completely unfettering the GPU from its power and thermal limits has given us an extra 20 points or thereabouts. You can see that the clock is a lot more stable, holding 1405 and 1392 P states quite easily. There's no fluctuations beyond that one, and the power limit only went as high as 114, so it's definitely got enough headroom there. So since we have this headroom now, why don't we try adding around 50 megahertz to the clock and seeing how that comes out. Let's check it out. Ooh, now there is a very handy bump to 5818 at 71 degrees. Having a look at the clocks, they've pretty much gone up by exactly 50 megahertz, so we know we've got no problems there, and the power limit's still at 117%. At 71 degrees gives us plenty of headroom to overclock further, so why don't we even try going to, say, 75 megahertz, for instance. Again, a nice bump, 5885 points now, 72 degrees, still well within spec, and we can see from our graphs that our clocks are still nice and stable and our power limit's still 118%, so we can push further again. This time around we're going to bump the memory 250 megahertz. That will give us a decent jump to the power draw, as well as run 20 millivolts on the core just to pump some heat in there, just to see how much headroom we really have. And on the second attempt on this run, we've managed to crack the 6,000 mark. The run before, using the 20 millivolts, it seemed to go backwards. I'm not sure why, but it scored at least 100 odd points lower. You can see the results to the left over that side. It power limited hard. Now dropping that 20 millivolts off kept us back down in the 111s, 112s, sort of the teens area, which is really puzzling because it shouldn't have done that. It did. Maybe it was just run to run variance, but it definitely ran better the second time around with the millivolts taken off. So the plan now is to run even more core frequency. We'll run it up to 100 megahertz on the core, as well as the 250 on the memory. See if we can really start to knock on that power limiter if we can. And oh dear, we seem to have gone backwards, ladies and gentlemen, boys and girls. Let's have a look at our graphs. Our clocks are stable and our power limit's way down. So it's not gearing down due to a lack of voltage in the P state. We're not getting throttling. This is really odd. I'm going to try adding some voltage, just a little, just to see if that stabilizes it. It should have shown up as gearing down the P states if the voltage wasn't enough, but we'll give that a test, and fingers crossed. 6,113, baby! If you can't tell, I'm quite happy with that score, managing to pull that 1 degree under the original stock temperature range. This is how I feel right now. I say, And getting back to business, our clocks were quite stable, so that's nice, and our power limit, we're starting to hit it at times, so I think this is a nice place to leave the clocks, especially with the temperature. I think what's left to do now is to run some Firestroke. And a few moments later we have the results, and we've managed to pick up about 1,000 points over the mark we made in the previous benchmark video when we did the is Sandy Bridge GTX 970 combination enough for today's gaming. So 1,000 points in Firestrike is nothing to sneeze at. So wow, I think I've earned a whiskey or two. Let's go have some of those, yeah? So there we have it, folks. Those are the results. Not too bad over the stock cooling solution. We managed to pick up, remember, 100 megahertz on the core, safely 250 megahertz on the memory. I was a little bit iffy about overclocking memory with those two tiny little fans trying to cool it all off. We managed to also pick up 440 points in Unigen superposition on high settings, all the while running 1 degree cooler. Last but not least, of course, we picked up 1,000 points in 3D Mark Firestrike, which roughly puts it on the same amount of score, roughly on par with my old overclocked reference RX 480. So I'm going to say it was definitely worth the time and effort to go ahead and do those mods to the graphics card, whether or not you feel it was worth the time. That's up for you to decide. If you've got an opinion on what all went down, leave a comment in the comments section below. Thanks for watching. Have a great day.